Cancer is New Zealand's biggest killer. More specifically, 1 in 10 New Zealand men will get prostate cancer, and 1 in 3 people in New Zealand will get a non-melanoma skin cancer, and 1 in 15 will unfortunately suffer a melanoma at some stage in their life. We are the Eureka team from King's College, and we aim to provide a little light and hope in this area.
One of the underlying reasons why cancer is so deadly is that detection tests are costly, time-critical, and often painful. As you would expect, this area receives a lot of attention, which brings us to our friends at the Photon Factory, a research facility at the University of Auckland.
Here they've been using lasers for research and innovation, including 2 projects under Dr. Michelle Newell and Dr. Claude Aguguri, which uses Raman spectroscopy to provide reliable, safe, and instant diagnosis for these cancers.
The key phrase said earlier was Raman spectroscopy. It is a technique that uses monochromatic or single-coloured light to measure what molecules are placed before it. Laser light can be thought of as a wave, where its wavelength defines the colour. If a specific colour is shot at these molecules, most is scattered back at the same colour, but a small amount is scattered back at a different colour or wavelength, and by recording this, we can find out what molecules the light hit. When the detector finishes analysing the light from the cells, it plots results on a graph of the Raman shift, or how much the frequency of the light source varies, to the intensity of the light at that frequency. Cancer cells have slightly different molecules in the cells from normal skin or prostate cells, meaning each graph will appear differently.
The researchers at the Photon Factory then uses AI and machine learning to spot the differences in these graphs accurately and consistently. So when you get your checkup, they will give you definitive results instantly. A spatially offset Raman spectroscopy measurement will make at least 2 Raman measurements, one where the laser beam enters and one a few millimeters away. A scaled subtraction will then be performed on the 2 spectra, producing 2 new spectra representing the subsurface and surface.
So how do the laser methods compare with current methodologies? Well, a doctor at the moment has to evaluate whether a suspicious portion of skin is cancerous, which is extremely difficult to do in some cases. If your doctor is unsure, they conduct a biopsy for the histopathologist's specialists to inspect the tissue under a microscope, comparing it to healthy tissue.
This is a gold standard, but can in difficult cases be subject to misinterpretation. This uncertainty can lead mistaken identification of tissue damage as benign and non-cancerous. Also, benign lesions are often unnecessarily removed and excessive cutting takes place.
Well, the Photon Factory tests for skin cancer would be very quick and easy, as it can be done by simply pressing the handheld device against the suspicious spot by a nurse, GP, or dermatologist.
The laser probe can also help by observing the effect of depth scattering to view tissue at different depths, maximizing tissue retention as well as allowing the doctor to find the extent of the cancer before removing it.
Prostate cancer is much harder to detect traditionally. There are 4, if not more, different scans, tests, samples, and although the process of obtaining the samples is painful. This process can also take months, as the prostate must heal before more samples can be taken.
As you can see, the technology the Photon Factory is developing is very promising, and it's actually well on its way to the public. New Zealand is the skin cancer capital of the world, with a melanoma rate at 6 times the global average of sufferers.
Our country is a beautiful place, but clean air and a damaged ozone layer above leads to high UV radiation, meaning we need effective ways to help prevention by early detection. This technology has the opportunity to also benefit rural New Zealanders who don't have access to the dermatology clinics. Diagnosing cancer earlier ensures the treatment is less severe and allows doctors to localize the cancer cells as they are less developed.
This substantially reduces the mortality rate of these cancers.